Ladies, this is our final example in section 4.2 on optimization. This is the toughest of all of the examples that we've worked. I'm going to do my best to try to explain it to you as clearly as possible, and I hope that you'll show a little grit and stick with me through this problem. A tank with a rectangular base and rectangular sides is open at the top. It is to be constructed so that its width is 4 meters and its volume is 36 cubic meters. If building the tank costs $10 per meter square for the base, so that would be $10 for the area of the base, and $5 per meter square for the sides, what is the cost of the least expensive tank? And what are those dimensions? So I want to begin by drawing this figure so you have an idea of what it is that we're looking for. All right, so here's our tank. I want you to remember that it said that it has a rectangular base and the rectangular sides and that it's open at the top. So we're not going to have to do any construction for the top. What is being maximized or minimized? Well, let's look back through the problem where let's find the word that would express maximized or minimized. And that would be, what is the cost of the least expensive tank? We know least would tell us that we're looking for what's being minimized. So the cost of the tank is being minimized. Okay. All right, so the cost of the tank is being minimized. The equation is not quite as straightforward as the equations that we have looked at before. So I want us to think about this figure and what we can go ahead and label. So we're not going to work in exactly the straightforward order that we've worked the previous problems. I know that it says that the volume is 36 cubic meters, so I'm just going to come over here and write volume equals 36 meters cubed. It said that its width is 4 meters, and so I'm going to determine that this length right here is the width. Now if you want to call this length the width, that's fine. It does not matter. So I know that the width is 4. I'm going to call this distance x, and I'm going to call the height of the tank y. Okay, so we've now labeled our tank. So let's look back at cost. It says that the base is $10 per meter squared. So my cost is $10 times the total number of bases. Well, we have one base. That base is a rectangle, and that base is has an area of length times width, or x times 4. So I'm going to multiply 10 times 4x. And I'll put $10 here to help you remember that that's $10 times the area of the base. So that takes care of the area of the base. Now we need to add the cost for the area of each side. Well, we have 4 sides, 1, 2, 3, 4. Remember, we're not calculating the area of the top because the top is left open. So let's multiply $5 times the area of the sides. Okay, so we have this side here. We know that its width is 4 and its height is y. So this area would be 4y. We have 1, 2 of those rectangular areas. So we would multiply 5, the cost of the sides, times 2 times 4y, because we have 2 of those. Okay, let's look at our additional sides. We have the front section here, and we have 2 of these. This area is x times y, and we have 2 of these. So again, we will take $5 and we'll multiply 5 times 2, because we have 2 of these figures, times its area, xy. So our cost equation is 40x plus 240y plus 10xy. So as we were calculating the cost, we also had to incorporate that with the area of the base and the area of the sides. Well, now let's talk about our constraints. And we've already used our constraints somewhat when we were figuring the cost figure. So we know that our constraints are the fact that our volume can only be 36 meters squared. So the volume is 36 meters square. We could also say that the width equals 4 meters. We could also say that the base cost is $10 and the side cost is $5. Well, we've already used our cost, we've already used the width, so now we need to focus on volume. We know that volume of this figure is length times width times height. We know that our volume is 36 meters, and I'm sorry I wrote square, that should be cubed, 36 meters cubed. So our volume is 36 meters cubed. Now, let's fill in what we are representing with length, width, and height. So length, width, and height would be 4 times x times y. So now we have our constraint equation. Let's solve that constraint equation for one variable. You can choose whether you solve for x or y. I'm going to solve for y. So to solve for y, we would divide both sides by 4x. So our constraint equation, y equals 9 divided by x. So let's use the constraint equation to rewrite our min function in terms of x. So here's our minimum function. This is our cost, remember. So our cost is equal to 40 times x plus 40 times 9 divided by x plus 10 times 9 divided by x times x. So if we simplify that, we have a cost function including the constraint equation of 40x plus 360 divided by x. And in the last term, the x's will cancel, so plus 90. Let me check my work. Yes, okay. So how do we find those critical points? Remember, the critical points are the zeros of the first derivative. I want you to pause the screencast, find the first derivative, find the critical points. So I found the first derivative, set it equal to 0, and solved for x and found that x is equal to 3. And now let's confirm that this value for x is a minimum. So if we do a quick first derivative test, I'll plug in a value less than 3, and I'll choose 2. If I plug in 2, I do get a negative. A value greater than 3, I'll choose 100, and I would get a positive. So we are decreasing and then increasing, and so this is a minimum point. Now that we know x, we can solve for y, because remember we were asked for the dimensions. So to solve for y, I will plug x back into y equals 9 divided by x. So y equals 9 divided by 3, which is 3. So we now have our dimensions. We have 3 meters by 3 meters by 4 meters. And recall that we were asked to find the least expensive tank that we could build. So we would go back to our cost function and plug in our values for X and for Y. So the minimum cost, when you plug those values back in, is $330. So double check. Have we answered the question? The question asks for the dimensions. It also asks for the cost, and we have both. You can find your homework posted on Haiku under the assignments. Thank you, ladies.